right. So I am going to quickly run through what we would be going over in class today. Were I there, but you're there, so you can go over this. So in the Canvas page, and I'm not sharing this, but in the Canvas page, you actually have access. This is called today's activity. So for today's date in the module, you'll find this PDF, and you'll see that it has quite a bit of information in it. And we are not going to worry about this. For the most part, we're just going to look at the very first page of it. So we'll look at the other pages on other days. But we are learning some important rules here that we will be coming back to. All right, so let's just kind of run through these rules. And some of these that we're learning here are just going to be so common to find over and over again. So I'll specifically highlight the ones that you should have at the front of your mind every time that you're on the lookout for. So starting with this one, and hopefully this is something that you are somewhat familiar with. So this might not be the first time you've ever learned of it, but anytime you have two intersecting lines or segments, and it doesn't matter what angle they're coming in at, but if this is a line right here, and if this is a line right here, then what you're going to find is that these opposite angles are going to be congruent to each other. Okay, and we call those vertical angles. It's important that we know that those have a specific name. All right, so what you're going to be expected to know is you're going to be expected to be able to identify and say, hey, these two angles are vertical angles. All right, now it says here that A and B are equal. Sometimes what we say is the measure of angle A, and here's some notation that's important. So what this means right here is the measure of angle A is equal to the measure of angle B. And so the important thing is that these two are congruent. And here's kind of just to give you a heads up of where we're going with this. We're looking at a diagram right here, okay? So this is just a geometric diagram, no big deal. But then we're going to kind of move it through our translation machine right here, and then we convert it into an algebraic equation. So in the future, if you see vertical angles, you can actually convert this and you can say, okay, so this angle equals this angle right here. So therefore, I can set up an equation that looks like this. So that's the idea. We're going to be looking at a bunch of diagrams and we're going to be abstracting from it. We're going to be taking from the geometric diagram information from it so we can turn it into an equation. And that's going to be a really key concept as we move forward. All right, now, as I'm going to just add something over here on the right, which is going to be our abbreviations. In fact, I'm going to abbreviate abbreviations. That's kind of meta. All right, so when we're talking about vertical angles, I do not want you, if you are looking at vertical angles, I don't want you to have to write out vertical angles every time. So a shorthand we can do is just vert. And then this right here, this symbol means angles. The same one we used a second ago when we said measure of angle A. I'll just leave that up there. But this symbol right here just means angle. Okay. So the next one does not come up as frequently, but it's good to know. If you've got a smaller angle here, and this is kind of an important thing we skipped over before because of time, but when we name an angle, the naming of our angle is always using the vertex of it as the center point. So this right here, if I go from A to O to B, that is this angle right here. That angle is going to equal, let me change my colors right here, AOC, which is that one right there, plus COB. So notice that those two smaller angles, when they're adjacent to each other, and that's the word adjacent, when they're right next door, so you're familiar with that word, hopefully. When these two adjacent angles are together, we can add them together and they add up to the bigger angle. It's not a super complicated idea. I'm sure that kind of makes intuitive sense to everyone out there. So this angle right here, this angle plus this angle are going to add up to this one. This doesn't come up a whole lot, but when it does, I'll kind of help walk you through that. But If we ever talk about the angle addition postulate, we call it AAP. It's just shorthand for angle addition postulate. A postulate is just another word for kind of it's a theorem in a sense, but there is a difference between what a postulate and a theorem is, but we're not going to worry about that for right now. Okay, so anyways, two angles that form a linear pair are supplementary. That I'm looking now at the next one. So a linear pair, this is going to be one of the other big ones. So I'm going to put a star next to vertical angles, and I'm going to put a star next to this one. I'll give you the abbreviation in a second. Linear pairs, anytime you have a line that's cutting into another line, you will form a linear pair. So you're going to find this on so many diagrams. And it's just important to always recognize that these two are what we call supplementary. And supplementary means that these two angles are going to add up to 180 degrees. Why 180? Well, it's because a line itself is 180 degrees. We call it a straight angle, and that's half of a circle. So if this is my vertex right here, and I took this point and I went around half of a circle, I'd end up right here, and that forms this 180 degree angle. Okay, so now we've got these two angles, angle A and angle B right here, that add up to 180. So measure of angle A plus the measure of angle B must add up to 180 degrees. All right, and before we're done with this video, I am going to walk through a few examples. So the linear pairs, this is going to be abbreviated LP, linear pairs. Pretty straightforward. Okay, so and like I said, tomorrow, well, I didn't say it, but tomorrow in class is going to be a practice day with just these rules. I'm not going to throw new stuff at you tomorrow. So we're going to have 2 days to really master these ideas. All right, I'm clearing everything because we're going to look at the last two rules. This next one is kind of a weird thing, and almost you wonder, why do we need 2 rules here? But let's say instead of 2 angles, we've got 4 angles. And it doesn't have to be 4, it could be 3, 4, 5, 100. If we had a bunch of angles that all add up to a line right here, then these are all going to add up. It doesn't matter what these are, but combined, they're going to be 180 degrees. So, of course, the way we might write that is measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D all add up to, just a second, sorry about that, all add up to 180 degrees. All right, and this is what we call angles on a line. Angles on a line. And I just abbreviate the angles with that notation that hopefully you're recognizing regularly now. So this is when we have 3 or more angles. And so just really quick to explain why we have this rule and we don't just call everything angles on a line, and why we have linear pairs as separate. Linear pairs, I'm going to scroll up a little bit. Linear pairs happen all the time. It's hard to draw a diagram without one. I mean, you can, but so many diagrams, like if I just drew an X, well, look at this. This angle and this angle form a linear pair. This one and this one form a linear pair. And you get vertical angles on opposite sides, just to go back to that one. So linear pairs and vertical angles happen all the time. On the other hand, angles on a line, this is less common to get 3 or more angles that add up to a single line, but it can happen. I mean, and it will happen somewhat frequently. Okay, the last one is a good one to be aware of. It's called angles on a point, angles at a point. And so the point that we're talking about is this one right in the middle. Notice we've got 3 angles. This is DBC. Of course, we're calling it CBD, so that one is right there. Let me change colors as I go through this. This angle is DBA, and remember the way I name it is I start with D, come down to the vertex B, over to the other point A. So there's my angle. And then I've got angle ABC right here, ABC. So here's angle ABC. These, if you notice, When I add all these up, it forms 360 degrees. Going in a full circle is 360 degrees. So when I add up all three of those angles, I'm going to get 360 degrees. And we call that angles at a point. And I even do a abbreviation for point, just PT. So this one is angles on a line, and this one's angles at a point. All right, that's all good. So those are the rules that we're going to be looking at today. And I encourage you to come back and watch the explanation for these angles again, rewind or track back in order to find out anything that you're missing from this if you kind of forget what some of the rules are referring to. So this is a reference that's available for you. Now I'm going to change what I'm sharing to look at your homework for tonight. And your homework for tonight, you're going to be doing all of the odd problems on this page. So I'm going to run through some of, not all of, but some of the even numbers. Okay, so now this right here, the instructions say identify if these are, I'm going to change the color so it stands out, complementary, linear pair, vertical, or adjacent. Now, we're not necessarily going to worry about the complementary. So instead, we're going to think about which rule would apply. So if I start with number 2, I've got angle B and angle A. Now those are not a linear pair because this is not a line. That is something else. It's just an angle. So what I could do here, if I had the situation, the only rule that we learned that would apply is the angle addition postulate, which says that angle B, or I'll just write it this way, measure of angle B plus the measure of angle A equals, and right here, I might call that the measure of angle, I'll call that angle C. It is not actually labeled. But anyways, the important thing is that this is a situation where I could use the angle addition postulate. All right. For this one, this number 4 is kind of tricky because I just see 2 angles, angle B and A, except I have this other angle right here. And we already talked about that. We call it a right angle. So I know that this is 90 degrees. So this would be a situation where I could do angles on a line. Now, it might not jump out at you right away as being the correct answer, but notice that I've got a straight line right there. So if I took the 90 and then plus B plus A, so I could say 90 degrees plus the measure of angle B plus the measure of angle A, that would have to add up to 180 degrees because that's a straight line. So that is kind of how you could approach this. Same kind of thing. Now 6, I will tell you, I'm a little bit flexible on this part of the assignment because we're not going to be doing stuff exactly like this moving forward. So if this is something that you kind of see this, oh, I'll just call this angle C. You know, if you want to do this as angles on a line again and call it, you know, these 3 add up to 180 because that is a straight line right there, you know, then we'd have the measure of angle A plus the measure of angle B plus the measure of angle C all add up to 180 degrees. All right, so that would be an appropriate way of doing it. All right, and you're not doing this problem for homework, so you know you don't have to dwell on that one too hard. But if there's one like that for your homework, you can think about which one makes the most sense. Okay, and then right here for 8, we've got these 2 angles, A and B. Now this, you could say, oh, if I had all these angles, I could do angles at a point. And you're right, because we could add all this up, we get 360 degrees. So angles at a point is not a bad thought. But if I focus on just the 2 labeled angles, I could ignore every other angle here. And you might have to look at it for a second, but what we really have is a situation where we're looking at vertical angles. All right, we just have this line and this line. I could ignore the other one there, and they intersect. The opposite sides of the intersection are angles B and A. So here I could say the measure of angle A equals the measure of angle B. And there we go. That's kind of the rule that would apply for this particular problem. All right, so the only answer I'm looking for when you submit this as your homework, like if I had you do number 8, you just say vertical angles, and that would be good. We're gonna get more practice with this tomorrow, so we'll really solidify what we're talking about here. All right, so if I look at this next part, I'm not gonna do all of these problems. Let's pick 16. Okay, so 16, there's a problem like this up above where it doesn't give you numbers, but now notice, this is more like what we're gonna do when we have problems to solve. And notice we have this diagram. I wouldn't say it's complex, but it's, you know, there's a lot of stuff going on here. But the only stuff we care about is this angle 49 and this angle B. And if I only focus on those two angles, what I can see and what hopefully you can see is that this right here is a straight line. So this one right here, and I've got two angles that have to add up to the angle of that straight line. So this is a classic example of linear pairs. So that is a linear pair. And what linear pairs tells me, and you might need to go back to your reference sheet and remember that measure of angle B plus 49 degrees has to add up to 180 because they are supplementary. That's the word we use. So now this is just an equation. Measure of angle B plus 49 equals 180. So I'm going to subtract 49 from both sides. And the measure of angle B is 131 degrees. All right, and that's my final answer. So this is what I would want to see for your problem. It would be great. Actually, I want you to identify which rule you used to solve it, and then what your answer came to. So if I look down at this one, the rule here is that this is just like the one we looked at before. That's a classic example of vertical angles. And it's nice when you have a problem like this, vertical angles. And I know that means that the measure of angle B has to equal the opposite side, which is 73 degrees. Look at this. No calculation required. I'm done. I do need to know I'm using vertical angles, but that's it. Okay, we will probably go over some of these problems in class just to make sure you guys got it. But go through all the odd ones, and we're not quite done yet because I wanted to do just a little bit more. These problems get a little bit more complex. There's only 2 of these. But what I have here, and I'll look at problem number 20 and call that good. All right, so with 20, I need to first of all look at this and realize what rule I'm using. So with this, I can see I've got an angle here, I've got an angle here, I've got this angle going all the way around. So it looks like these are 3 angles that all add up to a circle. And so this is going to be a classic case of angles at a point. Okay, and what angles at a point says is take your 3 angles. I'm going to color code them real quick. So I've got this angle, I've got this angle right here, and I've got this angle right here. Sorry. This angle right here, there we go. And that means that the measure of, well, it doesn't even tell me. So I'm not even going to write the measure of. It doesn't give me an angle name. So I'm just going to say x minus 24 plus 29 degrees plus 296 all have to add up to 360 degrees because there's 360 degrees in a full circle. So just to color code that one last time, this x minus 24 was my red angle that I labeled there. The 29 degrees was this green angle, and the 296 was this blue angle. So when I add those 3 together, because they all add up to a circle, I'm going to get that equation. All right, now I can go through and just do the algebra and solve it. I'll first of all combine these 2 number terms. So when I add that together, I'm going to get 325 equals 360. And I can even do this, x minus 24 plus 325. So I just got to drop the parentheses for that. I can do that. Now if I combine those, minus 24 plus 325. So that's going to 325 minus 24, basically, x plus 301 equals 360. All right, sorry for that writing. So now I've got those combined. Now I can just subtract 301. And I get x equals 59 degrees. All right. So that is, it just gets a little bit more complex because we have something like this given rather than just a plain old x. But it's really not going to be too bad. All right. So hopefully you understand what to do here. And at this point, I'm going to stop recording. I'm going to stop the video here, work on the homework. And like I said, tomorrow's just going to be practice with only these rules. We'll add a few more slightly more complex problems that relate to these rules. But you can also, we can go back over any of these that you have questions on. So have a great day. I will see you guys tomorrow.